All right, GAC, Algebra 3, how we doing today? It's Coach Johnson. We're about ready to get started. Sorry for last night. We had some complications, forgot some things. It's kind of weird. I see myself in the background. What's up? Hey, but we'll get started here. We've got some people here. We've got Ryan, we've got Emily, got Chris, we got Monty back in the back. We've got a lot of people that are going to end up asking us some questions here. So we're about ready to get started. So hopefully you're ready. Get that review out. Let's get underway. All right? All right. Emily, I know you came in there, Ryan and Matthew and Chris. Do y'all have any questions at all? We'll kind of get underway and get started. Okay. Do this on the top right. The quiz should be right up there. All right. All right. So with that being said, let's get started on a problem. Again, I will have more in class that we can go through, and then if you have any questions off of that in class, you can kind of use that as well as a review. But we'll get started on numbers here. Let's see, Matthew, Ryan, I know y'all were here first. Do y'all have any questions, maybe a number at all?
So how do you?
Let's do this while the guys are thinking about that. Number 21. Just so everybody knows, number 21 will not be on the test, okay? So make sure you kind of know that. That one's a little bit tricky. The only reason or the only way that 21 will be on the test is if we give you a picture. So if we end up giving you a picture there, we should be good to go on number 21, all right? And Ryan and Matthew, what one did you say there?
6.
All right, let's look at number 6 here. This one says find the reference angle given that we have an angle at 5 pi over 4. Now, anytime we have a reference angle, we have two questions. The question is, where's the closest x-axis and how far are we away? That always helps me out because that kind of identifies what we're looking for. Now, the question really becomes what quadrant is 5 pi over 4 in? And we can kind of know that by knowing it's a little bit greater than 4, which is on the bottom. So what quadrant would it be in, y'all? Third, yep, that's exactly right. Ryan's right. And I hear y'all just at home like Dora the Explorer yelling at the screen. It'd be 5 pi over 4. All right? Very good. So y'all know what I'm talking about, right? Yeah. Just checking. Just checking. So now all of a sudden we know what is the closest x-axis. It would be the left side, and we look how far it is away by finding what theta is. So if we have 5 pi over 4 is the whole thing, we can then find what that smaller angle is by subtracting what? Yep, subtracting pi. Very good. Because if this is 180 up here, if I subtract 180, or in this case pi from 5 pi over 4, I know that if I get common denominators, which would be 4. Yeah, 4. So if we put on the bottom, we also have to put on the top. We subtract that, just like Emily said there, it'd be pi over 4 as my reference angle. Always note too that my reference angle will always be positive. All right, my reference angle will be. Now, it's a little different when you start getting into the tangent or tan inverse of tan and all that and go from there, which we can look at in class. But this right here will always be positive when we're talking reference angles.
Number 7.
Yep, number 7 is another one where if we have negative 25 degrees, we look at that one. What quadrant would that be in?
Quadrant 4.
Good. Remember, negative will always be going in the opposite direction. Some people have struggled with that and might end up tricking us on the test a little bit. So if that's negative 25 degrees, what's that distance, or what's the closest x-axis? Yeah, 0 right here, right? And how far is it away? 25 degrees. Very good. And we can leave it just like that. If I give it to you in degrees, you could give it back to me in degrees. And if I give it to you in radians, I want you to give it back to me in radians as well.
Would
right?
you know what mode to put your calculator in?
Great question. Let's see here. The mode is all dependent upon what I'm asking for. So like the one that says, hey, use your calculator to find, I'm going to tell you probably on the test and say, hey, I'm looking for degrees here, or I'm looking for radians here.
Okay.
It's a little confusing because there is one question on the quiz that came up in the Kahoot game yesterday in 7th period that said something to the effect of, use your calculator, simplify number 14. And a lot of people put D, which was 144.74, but in reality it was like B, because it wanted to give it in radians.
Got it.
For me, I'll tell you on the test, okay? I think it might be to where they want you across the board to put in radians.
Mhm.
So we'll probably use that more or less than the degree, but I'll try to remember to tell you that.
Okay, cool.
Or if you have a question, you can ask me.
I
right.
had a question about 12.
All right, 12.
Like,
Let's go to 12
what
there.
do you do for inverse?
Oh, yeah, this is a good one. So remember anytime, and let's do this. Let's go 12 and 13 because those are both good ones. Cosine inverse of -1 is our first one, and then our second one is tan inverse of -square root of 3. Well, again, in both of these circumstances, we're trying to find, when we have inverse, we're trying to find what the angle is. Whether that's in terms of radian or degrees is dependent upon what I'm asking for. Normally with the inverse, and we'll just make it across the board, I want you to give it back to me in radians, okay?
Okay.
So if I were to just create my my ranges here, remind me, what would my range be for cosine inverse?
One.
Yeah, it'll be quadrant 1 and 2, right? So it's from 0
Wait, why?
to 180. Well, remember with the inverse, and I could go into detail about this, why the ranges are the way they are. But remember with the inverse, anytime I have an inverse, I have two different values, right? Meaning, like if you remember at this one, what's up, E? Good to see you. All short teachers care, or whatever Thomas came up with,
Yeah.
whatever, which he'll fail anyway, but that's all right. So if this is positive here, that cosine, where will cosine also be positive? Down here, right?
Yeah.
So in quadrant 4 and in quadrant 1, you're going to have repeated values. Well, with inverse, we only need one of those. So to simplify, what we like to do is just go, all right, well, we know that the values are the same here. We only need one. We know that we can only go to 0 to 180, and that gives us our positive values and our negative.
Oh,
Okay?
okay.
Now, if you don't get that, that's not going to be something on the test that's going to nil you. Okay? So Emily asked a great question. You don't necessarily need to know that, but for those that are curious, again, that's the case there. And remember that from the first and fourth quadrant, from 90 to -90, that's sine inverse and tan inverse.
Oh, okay.
Okay?
So those are the only ranges, really.
That's where it's got to be in. Exactly. Exactly. So like for cosine inverse of -1, right? We've got to figure out where x is going to be -1. That's our goal, right? Find some angle where x is going to be -1. So first off, you've got to look at just our range. So you're only looking at quadrant 1 and quadrant 2. And as you look at that, I think there's only one place where cosine is going to be -1. And where is that? At pi. Yeah, 180. And we always give it in terms of radians. So we're going to give it, and we're just going to say that it's pi there. Again, you might say why, but remember that this is -1, 0. Therefore, my x will be -1 in that case. Okay, so again, that answer should be pi. Now, the next one is a little bit tougher, I'm not going to lie, because now you have to do a little bit more simplifying and solving to be able to find where tangent is -square root of 3. Well, remember, tangent is y over x, and so because of that, you know that out of quadrant 1 and 4, which is the two places where tangent has its range, where is tangent going to be negative?
Oh,
Tangent to be negative.
Yes.
Either 2 or 3.
It's going to be either 2 or 4, right? Because this one down here, you might say, why is tangent positive?
Oh, no, I didn't know that was 10. Yeah, 2.
Yeah, because remember, it's negative, which would make it positive because it's y over x, all right?
Yeah.
Does that make sense? Matthew, does that make sense there? If not, there's other people at home that probably struggle with it too.
Yeah.
You're not the only one, so you're not bothering anyone. Plus, you're here. So,
What is the 2 before? I'm confused on where you got 2 before.
okay, so we're talking about where is tangent negative, right? You remember this? All short teachers care, right? All that jazz, or however, whatever acrostic you want to come up with. These two places are where the tangent is positive. Okay. The other two that's where
So
tangent's
this-
negative.
You meant the quadrants.
Yeah.
Correct.
Okay.
All we're looking for is where's tangent negative
Okay.
in quadrant 2 and 4. And so Matthew, question now, which one can we eliminate out of 2 and 4 with where we will have, where we'll be looking for? Tangent inverse.
Delete the number 2
Nice. Why?
because didn't you just say the tan inverse was 1 and 4?
Yeah, it's got to be either in 1 or 4. That's exactly right. So
Why does that have to be in 1 and 4?
Because remember, tangent inverse has our range, right? Has a range in that way. Our range has to be either in the first or fourth quadrant, right? It can't be anywhere else. That's why every time, first thing I would do when I come to my test would be to do that right there, to just draw that.
Cosine inverse is only in the first one.
First or second. And then sine inverse and tangent inverse is from 90 to negative 90, and it is in the first or fourth, okay?
The first or
First or fourth. And again, we'll review this again a little bit more today, but this right here, for those at home, again, this is probably tougher of the concepts that we've gone through. One of the toughest ones here. Okay, so now we've got to figure out when y is over x, are we going to get negative square root of 3? Well, we know we're in the fourth quadrant, so we can focus on that one. But where, when I put y over x, okay, will I get negative square root of 3? Well, if you look at your unit circle, you remember that there's really 2 locations you could look at. One being where it's square root of 3 over 2, comma, negative 1/2, and where these are flip-flops, back and forth. So one of those is going to produce negative square root of 3. Here's one way I remember it. Again, you could kind of take it or leave it. If I did y over x here, the square root of 3 would be in the bottom because it would be negative 1/2 over square root of 3 over 2. When the square root's in the bottom, that will always produce square root of 3 over 3. Okay? Always. Now the sign may change, right? But it will always produce that. So I know I can't have this one over here. I've got to actually flip-flop those. So now I'm looking for one where, and again, it's easier if you have a unit circle, but I'm looking for one where it's 1/2 comma negative square root of 3 over 2. So if I did y over x here, square root of 3 is on the top. So now that's going to produce, when I simplify, negative square root of 3. Well, where is this going to be the case in quadrant 4? I believe it should be 300 degrees. Okay? Now here's where the hop really occurs, where you really got to kind of know your stuff. So if we're at 300 degrees here, when we go around, that's 300 degrees. I can't give it in terms of 300 degrees.
Subtract.
I've got to get it to where, remember, it's 90 to negative 90. So from 0 down, I've got to actually go in the negative direction to go downward to make it easier on when we plug it in and that sort of thing. So from 0 down, how much distance is that angle? 60.
Okay.
Because remember, the whole thing's 360. So from 300,
Oh, yeah.
from 0 down, that's negative 60. And so if we give it in terms of radians, we'll say negative pi over 3. Okay? Now, if you understand this one, you understand it. Because it's a lot of stuff. I get that.
So why is it negative pi over 3 instead of? Oh, so if it went the other way, it'd just be pi over 3.
Correct.
Yeah.
If it was up here and it was just positive square root of 3, it'd be up here at pi over 3 positive.
Could you kind of just solve it without the negative, and then since it's negative in the question, add that back again?
Yeah, you could do that. Yeah, you could do that. I'm back. I'm good with that. If that confuses you, you could kind of solve in the first quadrant and know that if it's negative, it's got to be in the fourth anyway.
Yeah.
So then it's just negative. I'm good with that.
That's
All right. All right. Hopefully people didn't just skip to this part because it looks really confusing. Just looks like a bunch of Skittles threw up on the screen. It's all right. We're good. All right. Next number. You'll have another number there. Go ahead, E.
Cosine inverse is in the first. Keep it right.
Yeah. So cosine inverse is from the first to second quadrant.
Okay.
That's 0 to 180. That's cosine inverse.
Sine inverse is in the fourth.
Yep. Sine inverse is from the first and fourth. So that's sine inverse and tangent inverse. Good. And that's from 90 to negative 90.
Tangent is also in the first one.
Tangent's in the first and fourth. Yep. Same thing for sine and tangent.
Tangent inverse.
Yep. Tan inverse. We're talking inverses here. We're not talking across the board just for inverses on that.
What's in this third?
Nothing's in the third. That's a good way of remembering.
And then the second is only cosine.
Cosine inverse is only second.
The first one has all three.
All three. Yep. All right. Any questions? 21 we're throwing out. Okay. So 21 just throw out for me.
If you're throwing that out, does that mean that we will have 17 and 19?
17 and 19 we will have.
Can
If
we
we're
do
doing-
17? I was like super confused reading it.
Yeah.
I think we got the answer right.
Yeah. Let's look at it. A surveyor's measuring the distance across a small lake. Yeah. I'll tell you what. I get this. I understand. Yeah.
a lot of
Matthew said he didn't see it. Make sure you look at the back because I know it seems as though it's over with, and I don't know what happened on that, but just be careful. It's measuring the distance across a small lake.
Yes.
And what the big thing that I saw on this is confusing
Wait,
to
didn't it
know.
give us the distance across the small lake?
No, it has not. But he said he set up his transit on one side of the lake, 130 feet from a piling that is directly across from a pier on the other side of the lake there. From his transit, the angle, Patty, I'm on a podcast right now.
Oh, okay.
Would you mind if I came back? I know I told you we could, talk. Could we just talk a little bit later?
Like in class?
Yes. Yeah, if we could, that'd be great.
Okay.
Thank you. No, you're good, dude. That was my fault. That was my fault. We'll talk later. You're good. So if the lake, he set up his transit on one side of the lake, 130 feet from a piling that is directly across from a pier on the other side of the lake. From his transit, the angle between the piling and the pier is 30 degrees. See, for me, confusing question.
Yeah. I was like, what does he mean as a piling?
Yeah, I think the big thing, I think what's happening is this. So let's say that this is the pier. I think it's something like this, to where this would be like 30
And then at the
degrees.
bottom, I put 130.
The transit on one side of the lake, I think 130 feet. I think 130 feet might be here. Let's see. Directly across from a pier on the other side of the lake. From his transit, the angle between the piling and the pier.
I think the piling's above the pier. And he's looking at the pier from over here. You know what I'm saying?
What do you
Yeah, where'd you put? Did you put
I put
130 feet
130
here?
on the bottom, and I did tangent 30 equals x over 130, and then solve for x by multiplying it by
You put the angle here, right? You put the angle here?
Yeah.
Okay.
Mhm.
And you set that as x, right?
Yeah.
If you did it the other way, couldn't you just do cosine of 130 equals, cosine of 30 equals
Yeah, it just depends on what,
30 over x?
if you use tangent, cosine, or sine.
Yeah. All right. Y'all, here's the thing. If I gave a problem like that, I would include a picture.
Yeah, an image.
Okay. Unless it was guaranteed. All right. I'll tell you what, like for instance, if I gave you this picture right here at home, then you could solve that. I
Yeah.
think everybody in this class could solve it.
Yeah.
And so that's what I'm looking for.
Okay.
The only one that I might give to you is one like I did over there in the other building. If I say a shadow is casted at a building that's 50 feet, right? The angle of elevation towards the building, here's the building right here. The angle of elevation towards the building is 50 degrees. Find the height of the building, okay? So again, if I am going to make you, if I'm going to make you do that, I'm going to give you one that we've done before, one that's a little bit easier.
Okay.
The lake one I don't like, although if I gave you this picture here,
You could do it.
yeah, and that's what I want you to do is take that and go from there. I think it's open interpretation. Personally, I don't even know what the heck a piling even is. So that's probably my problem there. But again, we should be all good moving forward. So yes, I'll do number 19. Also, before we get to 19, side note, you all are in here, so I'm going to give you a hint on the test. I'm going to make you come up with your own word problem. Okay?
Like the form that
You
I'm
come
gonna
up
write
with,
about a piling.
yeah. No, yeah, you don't have to make about a piling. No, you don't. You can make it about anything, but you could come up with your own word problem, very similar to what we did over on the other side, okay?
Okay.
But just kind of giving you a heads up that that's kind of where we're going, and then we're rocking and rolling.
Did you get my text message?
No,
Did you not look at your phone? Or-
I didn't. I'm actually on a podcast right now.
Oh, okay.
So would you go ahead? You
I
good?
was just gonna tell you that I got caught in some pretty bad traffic. I left at 7. Usually
Okay.
I get here at 7:30.
Are you still good to take it?
Can I use it? Have enough time to take it right now? I have a free period, the second period of the day, that I can come by, and I know you have a class soon.
That's fine.
Okay.
That's fine. We're good with
Okay.
that.
Alright.
Sounds good. Thank you. Thank you, Tyler. All right, number 19. So like a word problem. Are we good on that?
Oh, you make them like 19?
No. Like what we did over in the forum.
Oh,
Yeah, just like where you come up with your own angle. You don't have to find it
Oh.
like before. You just come up with your own stuff.
okay, yeah.
You know, hey, I'm 10 feet away from the base and you know that. That's not information that I'll tell most anyone else, okay? So we'll be good to go. All right, so here's a ship on 19. It is 14 miles west and 42 miles south of a harbor. So let's do this. Let's put the harbor here. And so if I start with the harbor, I know I go so 14 miles west, 14 miles, okay? And I know I go 42 miles south. All right, so we're good right there. Now the next part is what is the bearing from the harbor to the ship, okay? Now, you got to kind of figure out at that point at the harbor, you create, and hopefully you can see this because I know sometimes hard to get it aligned, but that is my x-axis where this is my y. So what I'm trying to do is find where that bearing goes. Well, I can figure that out first by finding what this angle is that's between the x-axis and my bearing there where I'm traveling. So to find that, what I could do is what? Yeah, that's exactly right. Tangent inverse, because anytime I'm trying to find my angle, I use tan inverse. So if I do tan inverse of opposite over adjacent, I could use that, solve for it to find what my angle. 40, I think it's 42.
Wait,
42.
I did it from the other angle, like the bottom angle.
You did this one right here?
No, she did it from the
From the bottom, like from the boat. From the boat.
You did this one right here.
Yeah.
What did it say here? What bearing should the captain set to sail directly to the harbor? Ooh, actually, if I backtrack, I didn't read the problem right
Yeah.
because I thought it said from the harbor to the ship, but actually it wants to travel back.
Yeah.
So
it should be at a hypotenuse.
It's gonna be 14 over 42.
yeah, so if here's the ship, right? And that's why it's important to draw this because if I were to redraw it, now I'm really, if I'm going from the ship to the same direction, I'm actually headed from the ship towards this direction because that's where the harbor is.
So is it a hypotenuse?
Okay? Say that again, E?
Is it going to be like where the hypotenuse is for 14? That's what we should put it.
Not the hypotenuse because like, all right, so what happened was it went 42 miles down, right?
Yeah.
And 14 miles west.
Same thing,
Okay?
though. Like,
It's-
it is the same thing.
It's going to end up being,
Oh, opposite 14 over 2.
well,
What you're given. Yeah.
let me make sure of this.
So whenever you find an angle, you have to use.
No. I want to find
It just depends on where you put the data.
Yeah, well, yeah, I'm just trying to make sure on this.
You just do so.
I believe as we looked at this here, it went, so if we're here, right, and we're trying to find this angle right here, yeah, we're going to be good to go. We're going to be good to go.
The way you went.
Right here? Yeah, we'll be good to go.
It's
Now-
the same thing, though.
It really is.
Yeah, no.
Because now if we end up doing tan inverse
Don't have to solve.
of 42 over 14,
It would be 71.6.
71.6 degrees. So if that's 71.6, what would this angle be right here?
90 minus 71.6.
Which is
18.4.
good. Do y'all have the answers there?
Yeah. The answer. Oh, 18.4.
Is it B, the answer?
Yeah.
Yeah, because now I look at it, and if I solve this now, I have north 18.4 degrees east. Yep, that's it. Remember the angle's connected to the y-axis that's there. All right?
Can you do one more?
Yeah, one more. I'll finish off with one more here, and then I'll do more in class too, okay?
I was wondering how to do number 8. Actually,
Number 8's a good one. Tangent of negative 5 pi over 6.
Oh, yeah, you talking.
Yeah, this one's a good one. Remember, 5 pi over 6, if you look at your unit circle, will actually be right here. And the problem a lot of people make is they say, oh, it's negative, so I go the negative direction, but I'm still going to end up at 5 pi over 6. But that's not true. When you do this, you actually, to use your unit circle, might end up throwing you off a little bit. Now, I'm not saying don't. You just got to be careful. So instead of going to positive 5 pi over 6, now I've got to travel backwards. So do you see that this is the distance I traveled in the positive direction? So if I was traveling in the negative direction, I would actually travel the same distance, just in the negative way. Okay? So when I traveled backwards, don't look at your unit circle. It'll actually end up being 7 pi over 6, exactly, E. So it would be 7 pi over 6 in that way. That's where you'd end up settling, which is, if I was using tangent and I was doing that, I think it will end up being negative square root of 3 over 2, comma negative 1/2. Remember, if I did y over x, right, which is tangent, it'd be negative 1/2 over negative square root of 3 over 2. Matthew, does this make sense so far?
So I see the 5 pi over 6.
Yeah.
How you got up there. Why do you go the other way?
Because it's negative, right?
Okay. And you go the same distance, so that's how you got 7 pi over 6?
Exactly. So I went in the negative direction here, and we went from that point there.
So then 7 pi over 6, that's where negative square root of 3 over 2 minus 1/2 is.
Correct.
Yeah.
So how do you know to use so use tangent because
It's tangent.
It's given to you.
Okay.
And then that's y over x. Again, you can simplify this. Just a hint, when I start doing this, when you start, flipping it and all that, you can make mistakes. So whenever square root of 3 is on the bottom, remember, just a hint, what will I end up getting out?
Root 3 over 3.
Root 3 over 3.
And that's,
Yeah.
that's the only weird one you have to remember.
That's right.
You
That's
just have to
right.
remember that.
So we're absolutely. You don't even have to bring your own in. I've got so many over there.
What would it be if it was sine instead of tan?
Sine would be negative. What would be y, right? Which would be negative 1/2.
Okay.
Right? Cosine would be x. And then if you end up getting something like cosecant or secant or cotangent, find sine and cosine or tangent, whatever the reciprocal, whatever one's length, and then just flip it there.
How would you?
Yours is fancy.
How would you do
This.
15, coach?
Yeah, like mine is
When you
probably
actually
15?
find the angles.
Yeah, so does
I
mine.
know how to find B,
Yeah.
like the smaller B, the sides, but I don't know how to find the angles. Like,
Great question. E has had a question on number 15. Remember, we're setting up my triangle here.
oh, is it just tan inverse or cosine?
Actually, for the angles, it's fairly easy, right? So if no, I see what you're saying, because on 15,
Just looking for A and B.
yeah, so if this is 15.8 here and C is 23.3, those are what's given.
B is 17.1. I found that.
B is 17.1. We can use Pythagorean theorem to solve. So to find our big A and our big B, we can actually solve that by doing the inverse. Now you might say,
Just choose one.
just choose one. You could do
Anyone?
any one. Yep. It'll give you the same answer. So if I did cosine inverse of, let's say we're trying to solve for A, right? Angle A.
Yeah.
If I did that cosine of A, I do adjacent over hypotenuse. So I do 17.1 over 23.3. And if you solve for that, you'd find that you get the same answer as if you did tan inverse
Okay.
and did opposite over adjacent. So as long as you match it up, you're good to go. It's a good question.
So, Coach, I have a question about kind of the last problem.
Yeah.
You said that if it was
23?
or no, it was
Oh, the last one, I
number
guess.
8.
Yeah, number 8 still.
You said something about cosecant and
Secant,
secant,
cotangent.
cotangent. So what do you do if it's one of those? You said something about flipping.
Okay, so let's say I said it's cotangent of negative 5 pi over 6. We already found what tangent was,
So
right?
do you need to find tangent if say it is cotangent negative 5 pi over 6? Do you have to find tangent first?
No, you don't. You could actually just understand if you get that, if you can make that jump to do x over y.
Oh.
Because it's already flipped,
But
right?
you would go down at the same place. It would just
Same
be
place.
negative square root of 3 over 2.
Good.
Over negative.
Yep, so that'd be negative square root of 3 over 2 over negative 1/2. Thank you, Ryan. You're awesome, man, for coming. So remember, square root of 3 is on the top. So my answer would be just square root of 3, right? So you'd be good to go there.
Can
All
I
right.
just get a pass over?
Absolutely. Would you mind filling one out for me? All right. This is Coach Johnson's podcast. I hope you had a great time. I appreciate all those individuals who came this morning. And again, hopefully this helps you going forward off of your review. Again, if you have any questions today, we're going to use that time to answer those questions. Hope you have a fantastic day, and look forward to seeing y'all later on. See y'all. Bye.